Okay, May, June 2023, paper 1, variant 2. Question 1. Which single apparatus is used to find the volume of a solid cube? And which single apparatus is used to find the volume of a quantity of liquid? We want to find the volume of a solid cube, and then we want to find the volume of a liquid. The volume of a cube. Should I use a balance? Do I need the balance in finding the volume? No. Yes. Do I need the ruler to find? Yes, it's a solid cube, so I know its dimensions. So I need a ruler. What about the liquid? I need a measuring cylinder. So it is D. The speed time graph represents a short journey. This is the speed time graph. We can see that the speed is increasing, right? The speed is increasing. Which distance time graph represents the same journey? Speed is increasing. Which distance time graph shows the increasing speed? Is it A, B, C, D? Is it the same? Should it be D? Huh. Can I choose D? No, I cannot choose D. Why? Because this is constant speed. C is at rest. A is decreasing speed, so B is increasing speed. Yes, B is the increasing speed. Excellent. Okay. Question 3. How far does the car move between 0 and 5 seconds? How can I find the distance moved in a speed time graph? Speed time graph. Area under the graph. Excellent. So the area under the graph, this is triangle, basically half times 5 times 10. What's half times 5 times 10? 25 meters. Okay, good. Which statement about mass or weight is not correct? About mass or weight is not correct. Masses can be compared using a balance. Mass is a force. Is mass a force? Is mass a force? No, it's not a force. Okay, good. Mass is not a force. Which two quantities must be known to determine the density of a material? How can I find the density? Mass and volume. Yes, mass and volume. Two boys are sitting on a seesaw. What affects the moment of each boy about the pivot? What affects the moment? Moment, how is the moment affected? Moment equals what? How can I find the moment? Yes. His weight and his distance from the pivot. Yes. Force and perpendicular distance. Force and perpendicular distance. Okay, good. Question 7. A uniform meter ruler is pivoted in equilibrium at the 50 centimeter mark. A mass of 25 grams is placed on the 30 centimeter mark. What is the smallest mass that can be placed on the ruler to restore equilibrium? This is a good question. This is a good question. It's a bit tricky. You actually need to draw it. Okay, you actually need to draw this question. I know paper 1, you don't need to draw or you don't need to do anything, but for this question, you need to draw it to find or to actually visualize the answer. So we have a meter ruler, right? You have a meter ruler, which is pivoted at the 50 centimeter mark, right? It's pivoted at the 50 centimeter mark, right? Meter ruler means that it is 100 meters, 100 centimeters long, right? It is 100 centimeters long. A mass of 25 grams is placed on the 30 centimeter mark. So at the 30 centimeter mark, this is at 30 centimeter mark, you have a mass of 25 grams. 25 grams. You'd say, should I find the moment? Yes, you would find the moment. Should I find the weight or the force of this 25 grams? No, it's not. It's not that important to find the weight or the force. So we'll just use it as 25 grams. We'll consider the 25 grams to be the force. That's it for now. Why? Because we want to find the mass or the other mass in grams as well. So we will not convert it right now. Right? Okay. Now, a uniform meter ruler, a mass of 25 grams is placed at the 30 centimeter mark on the ruler. What is the smallest mass that can be placed on the ruler to restore equilibrium? I now need to restore equilibrium, right? You need to restore equilibrium. You need the smallest mass. Should I choose A, for example, because this is the smallest mass? Or should I choose B or should I choose C? Which mass should I choose? If you want to decrease the mass, okay, if you want to decrease the mass, then you need to increase what? You need to increase the distance, right? If you want to decrease the mass, smallest mass, then you need to what? Increase the distance. Okay. What is the furthest distance I can move from the center? What is the furthest distance you can move from the center? Hmm. No, it's not 25 centimeters. It's actually 50 centimeters. Why is it 50 centimeters? Because the distance from 50 all the way to the end of the ruler is what is 50. Isn't this at 100? Yes, it is at 100. So this distance would be what? Would be 50 centimeters. This distance is now what? 50 centimeters. What is this distance? What is this distance now? From 30 to 50, it's 20 centimeters, right? So the furthest distance is what is 50 centimeters. And this is the mass. This is the unknown mass. This is the unknown mass. Can I write an equation? Can I write an equation? Yes, we can write an equation. Force times distance, force times perpendicular distance would be equal to force times perpendicular distance. 25, the first one, times the distance, which is 20, right? This is quite clear because it's from 30 to 50, so the distance from 30 to 50 is 20 centimeters. From 25 to, from 30 to 50, 20 centimeters. Now the other force, I do not know the other force, but I do know the distance. I do know the distance, which is what? Which is 100, which is 50 centimeters. I know the distance, which is what? 50 centimeters. Again, why should I choose the 50 centimeters? Why should I choose the distance at 50? Because as you increase the distance, you will decrease the mass or decrease the force. Again, as you increase the distance, you will decrease the force or the mass. Okay, so 25 times 20, what's 25 times 20? It is 500, right? Equals F times 50. To find F, or to find the mass, divide by 50. Therefore, F would be equal to, or the mass would be equal to what? The F or the mass would be equal to 10 grams. It is equal to 10 grams. That's it. All we did is equilibrium. Force times perpendicular distance and force times perpendicular distance. We chose the other distance to be what? To be 50 centimeters. We placed the mass where? We placed the mass at the end of the ruler. We increased the distance as much as possible. Not 70 centimeters. Okay, again, the pivot is at 50. The pivot is at 50, right? So the maximum distance would be 50. Why? Because if you go this way, the distance would be 50 from 50 to 0. Or if you go this way, the maximum distance would also be 50 because from 50 to 100, that is the maximum distance. The maximum distance would give you the least mass or the least force possible. Okay? Question 8. Obviously, this test likes moment. But anyway, can I solve this question? Yes, I can solve this question. It's moment again. But for this question, you have 3 moments. You have 3 moments. Not just 2 moments, force times perpendicular distance and force times perpendicular distance. No, you have 3 moments. Why? Because you have a force 8 newtons. This is a force F1, right? And then you have force, another force, which is this unknown F, right? You have this unknown F. And you have a third one. You have a third force, which is what? Which is the weight of the beam. The weight of the beam acts at the center of the mass, at the center of the beam. This is the weight of the beam. So at this point, you have a force of 4 newtons. Therefore, we will need to solve this question, but using 3 moments. not just force times perpendicular distance and force times perpendicular distance. No, you need to solve it, okay, writing down three moments. How can I solve it using three moments? We need to differentiate between the clockwise moments and the anti-clockwise moments. We need to differentiate between what? Huh? The clockwise and the anti-clockwise moments. Which of these would be clockwise and which would be anti-clockwise? Yeah, the 8 Newton force, is it a clockwise or an anti-clockwise moment? 8 Newton force, it's rotating this way, right? Huh? Is it clockwise or anti? So this is anti-clockwise. What about the center of the beam? Is it clockwise or anti-clockwise? Yeah, this is also anti-clockwise. What about the force F? What about the force F? Is it clockwise or anti-clockwise? Yes, this is clockwise. So we have two anti-clockwise moments and one clockwise moment. Okay, that's the first part of the question. The second part, can I find the distances between each force and the pivot? Can I find the distances between each force and the pivot? Yes, I can. Let's go on. The first one, the 8 Newton force. What is this distance? What is this distance? This distance is what? Is 50. Excellent. This distance is 50. 60 minus 10 is 50. Great. So the first one, okay, can I write it down? Let's say, for example, um, let's write it down here. Okay, anti-clockwise moment equals clockwise moment. So force times perpendicular distance plus force times perpendicular distance equals only one force times perpendicular distance on the right hand side or the clockwise side. So the first one is 8 times 50, right? This is the first one. The second one is the center of the beam, the weight of the beam, force, which is 4 newtons times the distance to the pivot is what? What is this distance? What is this distance? Can someone tell me? This distance would be what? Yes, it would be 10 centimeters. Why would it be 10 centimeters? Because the center is at what? The center is at 50. The center is at 50. It's always at 50. It's always at 50, but for this question, for this beam, it's 100 centimeters long. So the center of 100 centimeter would be 50. The center of 100 centimeters would be 50. So the distance between the center 50 and the pivot, which is at 60, would be what? Would be 10 centimeters. This distance is only 10 centimeters. So 4 times 10 equals F, we do not know F, times the distance between F and the pivot. This is an easy distance. What is this distance between F and the pivot? 20. Yes, it is 20. So this distance is 20 centimeters. So F times 20. That's it. 8 times 50 plus 4 times 10. What's 8 times 50 plus 4 times 10? 440. Okay, this is 440 equals F times 20. To find F, what do you need to do? Divide by 20. Dividing by 20 would be 22. I know, I know. These two questions related to moment are a bit difficult. Okay, they are a bit difficult. Again, this is variant 2. Variant 2 questions might be a bit more difficult than variant 1 questions, but we need to get used to them. Okay, you need to get used to them. Okay, yeah. How is the distance between the center and the pivot? 10 centimeters, because the pivot is at 60 now. The pivot is at 60 centimeters and the center is at 50 centimeters. The center is always at 50 centimeters. So distance between 50 and 60 is only 10 centimeters. Okay. Hmm. Question 9. We have three toys, X, Y, and Z. Which is the most stable and which is the least stable? This is quite easy. The most stable would be X, because it's the closest to the ground. The least stable would be Z because it's the furthest away from the ground. Question 10. Diagram shows the energy stores for a mobile cell, what describes how chemical energy is transferred. How is how is the chemical energy transferred? يلا. How is chemical energy transferred? Chemical energy inside the battery, okay, gets outside of the battery. How does it get outside of the battery? Using the electric electrical energy. Electrical energy. Okay, any battery would produce electrical energy. A moving object is brought to rest by a resistive force of 50 newtons over a distance of 5 meters. What is the work done? The work done. Hmm. What is the work done? Work done equals force times distance. Okay, you have 50 times 5, which is 250 joules. 250 joules. Hmm. Question 12. Which two physical quantities must be used to calculate the power developed by a student running up a flight of stairs? Huh. Power. How can I find power? Power equals energy over time. So it is the work done and the time taken, right? The work done and the time taken. Hmm. Question 13. A rectangular marble block has dimensions of 1 by 1 by 5 and weighs 125,000 newtons. It is stored with the long side resting on the ground as in diagram 1. What is the change in pressure? What is the change in pressure, okay, when it is stored as in diagram 2 rather than in diagram 1? First of all, can I find the pressure? Yes, pressure equals what? Force over area, not just any area, the area in contact with the ground, right? The area in contact with the ground. Yes, the pressure will increase. Yes, it will increase. So A and D are cancelled. Yes, A and D are cancelled. By how much? That's the question. In the first diagram, the pressure was what? Force over area. The force is 125,000 newtons divided by the area in contact. What was the area in contact? This is 5, he said 5 meters, right? And this is 1. So 5 times 1 is 5, right? 5 times 1 is 5. So what is 125,000 divided by 5? 125. This is 25,000 newtons per meter squared, right? Or pascals. This is the first area. What about the second area? Pressure equals pressure equals force over area. The force is again 125,000 divided by the area in contact, which is 1 by 1, which is 1 divided by 1, 125,000, right? Pascals or newtons per meter squared. Newtons per meter squared. So this is the first, this is the second, and this is the first area. By how much did it increase? So basically you need to subtract 125,000 minus 25,000, which is 100,000 newtons per meter squared. So this is the amount by which it increased. Okay. Poor students describe the phrase absolute zero during a lesson. Which student is correct? What is absolute zero? Absolute zero Kelvin. Uh, zero Kelvin, right? It is 0 Kelvin. This is the lowest possible temperature. You cannot go below 0 Kelvin. There is no energy left inside the molecule. Okay? There is no energy left. 0 Kelvin. That's the absolute zero. Negative 273 degrees Celsius. Okay. Negative 273 degrees. So basically Kelvin equals Celsius plus 273, right? So to find 0 Kelvin, okay, if Kelvin equals 0, then Celsius would be equal to negative 273, which is the least possible temperature. In Antarctica, no, in Antarctica it's only like 230 Kelvin or something. Okay. In outer space, in the coldest areas in the outer space, maybe it would be 4 degrees Kelvin, 5 degrees Kelvin. Okay. To reach 0 degrees Kelvin, you actually need a special lab, and they haven't been able to reach exactly 0 degrees Kelvin. It's quite difficult to reach 0 degrees Kelvin. Okay, so 0 degrees is the absolute zero, the least temperature that you can reach. At the surface of a liquid, more energetic molecules can escape from the liquid to the atmosphere. This is called evaporation. Yes, it's called evaporation. Yes. A teacher puts some cold water into a test tube and starts to heat it from the top. Right? She starts to heat it from the top, which is wrong. Which is wrong. Why? Because we never heat anything from the top. We usually heat from the bottom, right? If you want to heat up a source or something, you will heat it up from the bottom. The water at the top boils, but she continues to hold the test tube as the bottom remains cold. It starts to boil. Hmm, How do you even heat it at the top? By bending it as she did in this picture. She just bent it a little. Okay, so the water at the top, and you have the candle or the Bunsen burner. Okay, at this point, so you're only heating up the top. Why? Because you've bent the test tube a little. Okay, which conclusion about the water is made from this experiment? How's the water boiling at the top? Okay, and the water at the bottom is still cold. Shouldn't all of the water start to heat up? Actually, no. Actually, not. Why? Why wouldn't all of the water heat up? Why wouldn't all of the water heat up? Is this water a good conductor of heat? Is water a good conductor of heat? No, it's not. It is a bad conductor of heat. Yes, water is a bad conductor of heat. Yeah, Mister, you should say that water is a good convector, for example, right? Convection happens, okay? Convection happens in the water, right? Yes, convection happens in the water if and only if, okay, convection happens in the water if and only if you start heating the water from the bottom. So that's why you say the hot water molecules rise up and the colder water molecules fall down due to the density, right? That's if you heat the water from the bottom. You'd say water is a good convector or air is a good convector. But in this case, the water molecules, the hot water molecules remained at the surface, okay, and the cold water molecules were not affected. Why? Because no conduction or very little conduction, not no, I can't say no conduction, huh? Very little conduction happened. Very little conduction happened. Why? Because water is a bad conductor. The molecules are further apart. No lattice vibration or very little lattice vibration. No free moving electrons. Okay? No free moving electrons. That's why the water at the top started to heat up and the water at the bottom remained cold. Okay? Hmm. Okay, question 17. Moving on to easier questions. Okay? Moving on to easier questions. What are the amplitude and the wavelength of this wave? The amplitude would be, what is the amplitude? It would be 3, yes. What about the wavelength? What is the wavelength? The wavelength is 8, yes. 3 and 8. Okay. Hmm. A light ray strikes a plane mirror and is reflected. Okay. Is reflected. Which angle is always equal in size to the angle of reflection? Which angle is always equal? Angle of reflection. It has to be the angle of incidence, right? Angle of incidence is equal to the angle of reflection. Which of these is the angle of reflection? Read them carefully, please. Which of these is the angle of reflection? Yes, the angle incident between the normal, right? Yes, so it is B. So it is B. Which labeled distance is the focal length of this lens? Which labeled distance is the focal length? Focal length would be B. Yes. Focal length would be B. A beam of light consists of yellow and blue light. Can I draw the yellow and blue light correctly? Uh, Yellow, blue, which would be on top? Yes, the yellow has to be above the blue. Yes. Hmm. Two devices shown. You have the medical scanning device and the remote controller. Which types of waves are used in these devices? Medical scanning and the remote controller. Yes, X-rays and infrared. X-rays and infrared. Okay, 20 was D, 21 is C. Hmm. Hmm. A boy shouts and hears an echo from a tall building 2.2 seconds later. The speed of the sound in air is 330 meters per second. How far away from the boy is the building? Can I find the distance? Yes, I can find the distance. Distance equals speed times time, right? But this is an echo, isn't it? Isn't this an echo? Yes. So distance equals speed times time, but over 2, right? Over 2. Um, 330 times 2.2 divided by 2, which is 300 and 60, right? Hmm. Okay. The magnetic field of a bar can be represented by magnetic field lines, which diagram shows the two magnetic field lines correctly. Which of these diagrams shows the magnetic field lines correctly? It's easy. A moves out from the north and into the south. A plastic rod is rubbed with a dry cloth. The rod becomes positively charged. Which has the rod? Why has the rod become positively charged? How can you make the rod positively charged? By losing electrons. You cannot gain neutrons, or neutrons don't even affect the the charge. Which statement about electric current in a conductor is correct? Hmm. Which statement about an electric current is correct? Hmm. In a DC circuit, electric current gradually decreases along the conductor. No. In a DC circuit, free electrons flow back and forth. They move in two directions in the DC circuit. They move in two directions. No, this is an AC circuit. Uh, AC circuit, the current remains exactly the same all the time. Isn't this an AC, an alternating current? It keeps on changing. That's the definition. It keeps on changing. It moves in two directions. So in an AC circuit, the flow of charge changes continually. Keeps on changing continually. Moves back and forth. Moves in one direction, then in the other direction. So this is an AC circuit. This is an AC circuit. Okay, which circuit can be used to measure the resistance of a resistor? How can I find the resistance of the resistor? With the ammeter and the voltmeter. Can the ammeter be in parallel? No. Hmm. Is B correct? Or is C correct? Is D definitely is wrong, right? Because the voltmeter cannot be in series. Huh. Should I choose B or C? Yes, I should choose B. Why? Because the voltmeter is in parallel, the ammeter is in series, so this is correct. A lamp rated 12 volts, 2 amperes is switched on for 60 seconds. How much energy is transferred? Well, we have an energy equation, which is E equals VIT. Hmm. Voltage is 12, current is 2, and the time is 60. 12 times 2 times 60. What is 12 times 2 times 60? Okay, it is D, right? Which ammeter shows the largest reading? You have a parallel circuit. Which ammeter shows the largest reading? A, B, C, or D? Which of them is correct? Yes, it is D. Why is it D? Why is it D? Because the current from this branch and the current from this branch will be added. They will be added at this point and will move back hmm, to the circuit. So you add both currents and then, for example, which is the least current in this question? The least current in this question, it would be A. Why would this be the least current? Because you have the greatest resistance. You have the greatest 2 ohms is greater than 1 ohm. So A would be the least current. B and C would be equal. B and C would be equal. Why would B and C be equal? Because they are on the same branch. And D would be the greatest. So let's say that this current is 2 amperes, for example. And this current is 4 amperes. This is 4 amperes. Therefore, the total current in this circuit would be 6 amperes. You just add them up. Okay, you add the 2 and the 4, which is 6 amperes. You have 2 lamps in parallel. You have 2 lamps in parallel. Which switches must be closed so that both lamps light up? You need both lamps to light up, right? You need 1, 3, and 2. 1, 2, and 3. Hmm. Question 30. Which statement about electrical safety is correct? Hmm. Which statement about electrical safety is correct? Yeah. If a device is double insulated, it does not need a fuse. Okay. Ah, how can I solve this question? You need to read it carefully. Read it carefully. Yeah. If a device that has a normal operating current of 3 amperes must be protected by 3 ampere fuse, if the device has a normal operating current of 3 amperes, then you add the 3 ampere fuse? No, you actually add a greater fuse. 4 amperes, 5 amperes, but not 3 amperes exactly. Switches must always be connected to the life supply. Switches must be, yes, they must be always connected to a life supply. The metal casing of an electrical device must be connected to a neutral wire. Metal casing must be connected, no, it must be connected to what? To the earth wire. If a device is double insulated, does not need a fuse? No, it does need a fuse, but does not need an earth wire. An earth wire. So the only correct answer is C. Okay, neutral wire was the negative wire, for example. So the metal casing is not connected to the negative wire, it's connected to the earth wire to prevent what? To prevent electrical shock. Okay, a student investigates. A student investigates the output voltage induced across a coil of wire by a bar magnet. When will the induced voltage have the greatest voltage, greatest value? When will the induced voltage have the greatest value? He is investigating the output induced across a coil of wire by a bar magnet. So a bar magnet which keeps on moving, right? You have a bar magnet which keeps on moving. Slowly, should I slowly move the, no, should quickly move. Leaves the bar magnet stationary, no, it will not induce any current. Quickly removes, yes, quickly removes. So the motion, you need to increase the motion. You need to increase the motion. In which device is the magnetic effect of a current not used? Not used. Yeah. Magnetic effect of the current not used in, yes, potential divider. a potential divider. We do not use the magnetic effect of a current, magnetic effect of a current in the potential divider. Question 33. We need to find the types of transformers X and Y. X and Y. Can I find the difference between them? Hmm. Can I find the difference between X and Y? Yes, I can find the difference between X and Y. First of all, these are transmission cables. In the transmission cables, do I need a high voltage or a low voltage? In the transmission cables, I need a high voltage, right? You need high voltage. So to increase the voltage, you need a step up transformer. And then, while going into the houses, should the voltage be high or low? You need the voltage to be low. So Y should be a step down transformer. It is C. Before the houses, you should have a step down transformer. Before the transmission cables, you need a step up transformer. Okay, good. X is a step up transformer because in the transmission cables, the voltages are very high. When you transmit electricity across very long distances, you need to increase the voltage and decrease the current. Which diagram represents the position of the charged particles of an atom? Which of these is correct? Yes, it is A. 35. The table shows the composition of three different nuclei. Which nuclei are isotopes of the same element? Same element. X, Y, and Z. Y and Z. Which of these would be the yes, only X and Y, right? Because they have the same number of protons. They are isotopes. Okay? All good? Question 36. A sample of radioactive isotope emits 9,600 alpha particles per second. After 40 hours, it has fallen to 600 alpha particles per second. What is the half-life of the isotope? So you started off with 9,600 and you reached 600. How did you do that? By dividing. You divided by 2 how many times? So 9,600 divided by 2. What's 9,600 divided by 2? This is 4,800. Then you divide by 2 again. 2,400. You divide by 2 again. 1,200. You divide by 2 again. 600. So after how many half-lives? After how many half-lives? After 4 half-lives, right? So you have 4 half-lives. The total time taken was 40 hours. The total time taken was 40 hours. So in 40 hours, you had 4 half-lives, right? You had 4 half-lives. So 40 divided by 4 is 10 hours. So every 10 hours you divide by 2. After 10 hours it became 4,800. After 10 more hours 2,400. After 10 more hours 1,200. After 10 more hours 600. So for example, if you had left this sample for 50 hours, it would have been 300. For 60 hours, it would have been 150, and so on. You keep on dividing by 2 every 10 hours. This is the half-life of this isotope. Which row states a harmful effect and a beneficial effect of ionizing radiation on living things? Harmful and beneficial effect. This is easy. Harmful effect mutates living cells. Beneficial effect kills cancer cells. Yes, C. Which statement about the solar system is correct? Which statement about the solar system is correct? All planets are rocky. Only Earth has a moon? No. Pluto is a dwarf planet. Yes, Pluto is a dwarf planet. There are many stars in the solar. No, only one star. So Pluto is a dwarf planet. Yes. Question 39. Which parts of the electromagnetic spectrum are P and R? Hmm. P and R. The sun. The sun emits different waves of the electromagnetic spectrum, right? And we know them. We know that the sun emits different parts of the electromagnetic uh, waves, electromagnetic spectrum, which are what? Which are the infrared radiation, light radiation, and ultraviolet, right? Infrared, light, and the ultraviolet, the UV, right? He's asking, so infrared, light, and UV are P, Q, and R, right? Are P, Q, and R. But the question is, which is P and which is R? It's quite obvious that Q is the light radiation. Light radiation is Q. P, Q, and R, they are in the order of what? In the order of increasing wavelength. In the order of what? Of an increasing wavelength. Right? What do I mean by increasing wavelength? So P actually has the least wavelength and R has the longest wavelength. P is the shortest and Q is the and R is the longest. P is the shortest and R is the longest. Right? P shortest, R is longest. So we know that when we write down infrared, light, and UV, this way, you're actually what? You're actually decreasing the wavelength, right? You're actually decreasing the wavelength. Why are you decreasing the wavelength? Because the UV has the higher frequency, right? UV and then X-rays and then gamma rays. Gamma rays have the highest frequencies and the lowest or the shortest wavelength. So as you're moving this way, the wavelength is actually decreasing. The wavelength is decreasing. Therefore, infrared has the longest wavelength and UV has the shortest wavelength. Infrared has the longest wavelength and UV has the shortest wavelength. So P has to be UV, has to be the ultraviolet, and R has to be the infrared. Why? Because it has the longest wavelength of these three. So it's D. P is ultraviolet and R is infrared. Okay. Question 40. An astronomer observes the redshift of the light from a distant galaxy. Which statement about redshift is correct? Which statement about redshift is correct? It decreases. It is the decrease in observed. No, it's actually the increase. It is evidence that the universe is contracting. Is the universe contracting? No, it's actually expanding. It is evidence that the universe is expanding. Yes, and supports the Big Bang theory. Yes, it is. Redshift is when the light from the receding galaxies appears blue. No, it appears reddish. The wavelength increases. Okay, the wavelength increases. Okay. Okay.